Hi folks, so let's continue on from what we started yesterday. So we're now moving into 2.4, the domain and range. So a reminder, the domain is all the values of the independent variable, which are your x values. The range is all the possible values of your dependent variable, which is your y. And then there's two sets of data that we use when we're describing domain and range. It's either discrete data, and by that I mean when you have a graph, there is separate distinct points. They are discrete from one another. Or we have continuous data where the graph is lines or curves that are continuous and attached. Now, going from there, when we're setting the domain and range, depending on if it's discrete or continuous, you need to know the symbols for inequality. So you have greater than or equal to, less than or equal to. Okay, and then most things can be, or most numbers can be expressed as part of a set. Okay, and it depends what set we're talking about, real numbers, integers, etc. So there are different ways you can write the domain and range. Interval notation is one of those ways. It also is the most efficient ways. You can see here we have a nice error in spelling, parentheses. Okay? So basically, when you have round brackets or square brackets that are reversed, it means that those values are not included in the graph. For example, you could either see that by seeing a hole in the graph. This means it is not included. It could mean that it approaches a value, but it never meets it. Okay, it could also mean that we're approaching infinity, and since we can never actually attain infinity, the value is not included. Okay, versus here, square brackets faced inward means the values are included. So typically you'll see something like either a solid point, a solid line. Okay, you will not see arrows, you will not see holes. So here are some examples of less than, greater than, and their notation. So I'm just going to show you one or two. So x is less than 3. That means that it would have started at the value 3 and then was less than. All the x values were less than that. So it goes all the way to negative infinity. So it's going to be between 3 and negative infinity, which you see in each of these, and you can either use those round brackets to say not included, or those reverse square brackets to say not included. And then let's go with this one. X is between 6 and 9 inclusive. So let's say this was 6 and 9, something like this. Okay, then you would use square brackets because 6 and 9 both exist and are included. So let's look at this one. So looking at the left-hand side of the graph, what is the smallest x value you can see? So I always imagine that I'm approaching in from the left, and what is the first x value I see? Well, that would be right here at negative 5. Okay? And then on the right-hand side, what is the largest x value? So again, coming in now from the opposite side, from the large positive x values, the largest one I can see, well, I see an arrow, which is a sign that it's just continuing on and downward. So that means it's probably going to be approaching a large infinity. Okay. So write the domain as an inequality and an interval notation. So let's start with interval because that's what we were just talking about. So negative 5 here is included, so we need that square bracket. Okay. And then over here, if we're saying infinity, it means that we're not actually going to reach infinity, so we have to do a round bracket. Another way of stating it, if you want to write it as an inequality, you can just say x is greater or equal to negative 5, because that includes all the values all the way up to infinity. So let's do the same thing, but with the range. So this time, what is the smallest y value? So coming up, well, it would just continue downward towards very large values of y. So the smallest y value is going to be a very large infinity, but it's going to be a negative infinity value specifically because we're on the negative side of the axis. And then at the top, what is the largest y? Well, that would be 5. So let's do the same thing. We're going to write it out in both senses. So it could either be 5 to negative infinity, or it could be x is less than or equal to 5. Okay, this time because all the values are less than 5. So let's practice writing some of these out here. Again, you can practice writing them in interval or set notation. You can also write it as an inequality. So x is from -3 to 8, so inclusive. So I could say x is between -3 and 8. Okay, if it's between those two numbers, it definitely has to be greater or equal to -3, and I'm putting that equal because it's inclusive, and less than or equal to 8. Okay, or you could write it as 8 -3 with square brackets like this. Okay, A is less than -6, and it's not inclusive, it's not stated there. So A is less than -6, which means if you were to graph this, we'd start at -6 down here, and it's everything less than, so we're going to a very large negative infinity value. So it's going to be -6 all the way to -infinity, and because it doesn't state that it's included, round brackets. Or, again, you could write it as the reverse square brackets as well. And just, this is important. Oops, sorry, that shouldn't be an 8, that should be an infinity. This is important because you may see on the exam that they use this notation versus this one. I'm just going to choose the last two here. So n is all real values. Okay, so when you want to write something of that nature, what we typically write is n is an element of, okay? And then for real values, you use the symbol that represents real values, which is this. So n is an element of the real values. So same thing, but for integers. Okay, x is an element, and integers is noted by a z that looks like this. And we'll go over the different symbols for different sets of numbers, but I just wanted to recognize these two specifically because it's the ones you're going to see the most often. Okay, so let's look at identifying the domain and the range for all these examples here and how we can find them in different forms, not just from a graph and not just from a sentence. Okay, so I just want to make note that these first three examples, A, B, and C, are examples of discrete data. If you were to graph these, they would be sets of points on a graph, not a line. Okay, so when you are stating the domain and the range of something that is discrete, you are just listing off the domain or the x values, and you are listing off the range or the y values, simply enough. Okay, so for this one, if I wanted to state the domain, I would say the domain are the values 2, 5, 7, and 9. Okay, so that's that set of values. You could start by stating domain here, just to be more clear. Range would be all the y values. So 3, 1, and 5. If a number is repeated twice, you do not need to repeat it. Okay, you could just write it once, save yourself some time. Okay. So for here, let's do the same thing, domain and range. Again, remember this is a mapping diagram. This just represents a table of values, so you could equally write this as -1, 4, -2, 6, 0, 8, and 1, 8. Okay. And an important reminder as well, if something here is not a function, we don't write the domain and range for it. Okay, so this happens to be a function. We don't see the domain repeating itself, so we're fine. This is a function. The domain is not attached to multiple range values. We're fine. But had these been something where a 2 repeated or a number over here was attached to multiple, you would not even need to list the domain and range. You could automatically stop. Okay, so for here, the domain, I'll list all the input values, so the first set here, so -1, -2, 0, and 1. Okay, and for the range, all the output values, so 4, 6, and 8. Okay, for this one, remember domain and range, it's just your x versus your y. You could graph this, it would be distinct points. So your domain is -3, 1, -2. And the range is 5, 4, and 6. Okay? And then for D, it's going to be a little different because we're looking at a line. So it is a continuous graph, which means we can't just list off values. But let's just really quickly draw what this would look like. So it would cross the y-axis at -1. It would have a slope of 2 over 1. So up 2 over 1. It would go like this. So if I look at the domain of that, well, the largest x value I see, well, it's an arrow, which means it's just going to be increasing towards really large values of x. The smallest x value I see is also an arrow, so towards very small values of x. So x goes all the way from infinity to negative infinity, which you can absolutely write like this, and it is correct in interval notation, or like this. Okay. Or if you want, that just means that every real value exists. So I could say x is an element of the real value. So every real number of x exists. Similarly, the same thing happens with the range. So you would see it could be this, this, or y is an element of the real numbers. All those are correct. Okay, last one, distinct set of points. You could represent it as a table of values, mapping, points, any of this. So the domain would be all of the x values I can read. So I did this by hand, so it's a little gross here, but let's say this is -3, -2, 2, and 5. And the range would be all the y values. So this is -5, 0, 3, and 3, but I'll just write it once. Okay, let's keep going. So now we're going to look at some graphs. Again, do the domain and range, talk about the strategy behind it. If you're feeling comfortable with this, just fast forward through. No issues. Okay, so for this one, the domain, we're looking at the x-axis. So I start coming in on the left. What is the smallest x value I see? Well, it's here, but there's an arrow, which means it's going to be a very large negative number, like negative infinity. Come in from the other side, again, an arrow. So it's going to be a very large positive infinity. And it's just going to keep going in both directions like so. Okay, so that means the domain, you can represent it with any of those things that we just talked about on the last one up here. Okay, so I'm just going to write x is an element of the real numbers. For the range, okay, so let's start with the y's. So if we approach from below, it is 4 is the smallest value I see. If we approach from above, well, these are just going to continue increasing. So we're really never going to be able to stop this graph from increasing. So you could either write y is greater or equal to 4. You could write that y is between 4, and 4 is inclusive because it's a solid line, and infinity. And again, we can't attain infinity, so it can be written like this or like this. Okay. Let's go here. So this one is very similar to this graph here with arrows on each side. So the domain would be x is an element of the real numbers. And for range, it would be y is an element of the real numbers. Okay. So for this one, looks a little funny. It's a sinusoidal graph here. So there are arrows. They're a little hard to see here, but they would just continue this graph doing the same oscillation as what you're seeing between these values. Okay, so for the domain, let's start with the x's. So approach from the left. Well, no matter what, this is just going to continue to the left. And coming in from the right, it's also going to continue oscillating to the right. So there is no limit to the x value. So I would write x as an element of the real values, or you can write that between negative infinity and infinity. Either of those is correct. And then for the range, well, if I were to approach from below, it seems to start here at 5 with a solid line. And if I approach from above, it seems to be here at 1. So it seems to be between -5 and 1. So I'm going to take a pause here while this video ends and continue on with the next video.